Hello, Math Studies students, and welcome to your online lesson. Today we'll be talking about the three main trigonometric functions, also sometimes referred to as trigonometric ratios or trig ratios. We will know we are successful when we can set up trig functions using the parts of a right triangle. So why do we care about trigonometric or trig functions? Well, they can help us find missing angles and sides of a right triangle. Previously, we've used the Pythagorean theorem, which allows us to find a missing side of a right triangle if we know other sides, but it doesn't help us find missing angles. And sometimes we have a certain combination of parts, like some sides, and we're looking for an angle, or we know an angle on one side, but we want to find another side, and trig functions or trig ratios can help us do that. The three basic trig functions are sine, which we abbreviate with sin, but we don't call it sin. It's not sin, it's sine. Same thing with cosine, cos, and tangent, tan. And again, we don't want to refer to these as sin, cos, and tan. If you think you might forget what those stand for, you can certainly write out the whole word as I did on the left here. But again, the typical way of writing it is just the three-letter abbreviation, but we still know exactly what those are referring to. So in order to use or set up trig functions, we first have to understand how the parts of a right triangle work in relation to one of its non-right angles. And what do I mean by non-right angle? Well, a right angle, obviously, is the 90-degree angle of a right triangle. So every right triangle also has two non-right angles. And here we have one that's labeled with the Greek symbol theta, and it's one of the non-right angles. And then in the second example, we have the Greek symbol phi, again representing one of the non-right angles. The things that we're most concerned about on a right triangle are the hypotenuse, which you can see abbreviated as HYP. And it doesn't matter what you're talking about, whether you're talking about an angle, a non-right angle, a right angle, a side. The hypotenuse is always the longest side of a right triangle, and it's always across from or opposite of the actual right angle. And so the hypotenuse is really easy to find. The thing that can change, though, is these words opposite and adjacent. For opposite and adjacent, we always have to be comparing it to a specific non-right angle. So what do we mean by opposite and adjacent? Well, as we've probably seen in a geometry class before, opposite is across from. So opposite means across. And adjacent means next to. So as we look at theta, this first angle right here, this non-right angle, there are three sides of a triangle. And there is one that is across from it. That would be BC. It's the one that is opposite. And we can see here, there's this arrow showing that it is across from our angle. And so that would be our side BC. There's also a side that's next to theta. And in fact, you might say, well, if I look at this angle theta here, there's actually two sides that are next to it. However, one of which we've already identified as the hypotenuse. So what we're looking for is the non-hypotenuse side that's next to or adjacent to our angle. And that is going to be over here, and that would be side AB. All right, now if we look at our second triangle, I'll clean this up a little bit here. We are looking now at phi, or this one that's got sort of a circle with a little slash through it. I'm circling that here in blue. And so once again, if I'm looking for the opposite, that's the one that's not next to it. It's not part of what's actually forming the angle. You'll see me tracing here the two sides that are forming the angle, but the one that's across from it. And so that would be this side right here. And so the opposite to phi in this case is side AB. The adjacent one is the side that's next to it, but isn't the hypotenuse. Again, there are two sides that are next to or even forming this angle here, but one of which is already classified as the hypotenuse. We're looking for the other one that's next to it, or the adjacent one, and that is BC. So another way to say this, instead of saying the adjacent or opposite side, we could say the adjacent or opposite leg. And as we know, the legs are not the hypotenuse. And that's probably a better way to actually think about this. All right, so now let's actually do an example where we find those parts. So here we've got a triangle XYZ. And the first thing we'd like to do is find the hypotenuse. And again, they don't even specify which angle we're talking about. There's two non-right angles given. One is alpha, one is beta, but we could call those angles anything. We could even call them capital Y and capital Z, but here they're referring to them as angle A and angle B. And it doesn't matter which one we're talking about because the hypotenuse is always the longest side. It's always the side that is across from the right angle. And so across from or opposite of that would be this side right here that I've just traced, which is side YZ. All right. Now I want the side or the leg of the triangle that is opposite of alpha. All right, so alpha we've got here has the vertex of y, and I want the one that's opposite. So what does opposite mean again? It means across from. And so I'm not looking for the side that's forming it, certainly not the hypotenuse, but instead we are looking for the one that is across, and that would be the side that I'm tracing here in red, which is XZ. So XZ is the side that is opposite of alpha. Now I want the side that is adjacent to alpha. And again, we already know that this side right here is our hypotenuse. And so if we look at alpha here, we want the side that is next to it, but isn't the hypotenuse. And so that's going to be this side right here, which is side XY. All right, now I'm going to clean this up a little bit because we're going to look at beta. So we're switching angles that we're talking about, circling beta here. And now we want the side that's opposite beta. Again, so not touching it, but across from it. And so that is going to be XY. And then finally, the one that's adjacent to beta. Well, again, there's two sides that are next to it, but one is already the hypotenuse. And so we're looking for the leg, and that's going to be this XZ right here. Now, interestingly enough, if you look at this, we had some similar answers. For example, part C and D had the exact same answer here. XY. On one, it was adjacent, and one, it was opposite, because we switched angles. And so, like if I'm looking at XY, which I'll highlight in red here, that is next to or adjacent to alpha, but it is across from or opposite of beta. So it's really important that we focus on which angle we're talking about when we deal with adjacents or opposites. Remember, the hypotenuse, though, will always be in the same position regardless of which angle we're talking about. As mentioned in our opening notes, that there are three trigonometric functions, also referred to as three trigonometric ratios, or trig ratios for short. And what we mean by a ratio is essentially just a fraction. And so sine, cosine, and tangent all represent a fraction of that's put together with sides of the triangle. And so sine takes that opposite side, the side that's across from the angle that we're referring to, and puts it over the hypotenuse. So opposite over hypotenuse is our sine. Cosine takes adjacent over hypotenuse, so the side next to our angle theta. And then finally, tangent, again, looks at our angle theta, one of our non-right angles, and puts the opposite over the adjacent. To help remember these ratios, people often use an acronym or an abbreviation known as SOHCAHTOA. SOHCAHTOA is not an actual word. It just rolls off the tongue pretty easily, and it helps us remember the different ratios. So SOHCAHTOA, we've got S, C, and T, which stand for sine, cosine, and tangent. And then the letters after it, we've got O's, H's, and A's, representing opposite, hypotenuse, and adjacent. So sine is opposite over hypotenuse, just like we saw here. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So a lot of times when we have to deal with setting up trig ratios, right away on my worksheet or test, I will write down this acronym, SOHCAHTOA, so that I can more easily remember which ratios I need for each non-right angle. All right, for our final example here, we're going to set up some ratios. In our next video, we'll actually use those ratios to find missing parts of a right triangle. But to begin with, we're just setting up the ratios. So for part A, we're doing the sine of theta. And you'll notice here they're referring to both theta and phi throughout this example. So there's different symbols. And you don't even necessarily need to know what they're called. Theta comes up very common as a missing angle value. But, you know, phi, as long as you match up the symbol, that's the important thing. So again, part A, we're looking at sine. And again, it's the sine of theta that we need to find. So on our picture, we need to actually look for theta, which is over here. Now, also we need to remember, what does sine mean? So I'm going to write down my acronym, SOHCAHTOA, right here. I use the capital letters to remind us the name of the trig function or ratio, and then lowercase letters to remind us of our opposite, hypotenuse, and adjacent. So the sine of our angle theta is looking for opposite over hypotenuse. O and H we have right here. So opposite means across from. So I've got this angle theta here, and what is across from it is this side right here, which is a lowercase b. Again, we're making ratios or fractions. The next thing I need, it's SOH, so opposite over hypotenuse. Well, the hypotenuse is always the same. It's always the longest one. It's always the one that is across or opposite from our right angle, which in this case would be C. So sine of theta is B over C. And that's setting up a trig ratio or trig function. Moving on to part B. Here we are looking for the cosine of phi. So I'm going to erase my tangent, or my theta circled, and we're going to go to phi. I'll circle it here in red. And for this one, again, we're looking for the cosine. And so for the cosine of phi, I need the adjacent over hypotenuse. Well, adjacent is the one that's next to it. Remember, the hypotenuse is always next to it as well, but we want the leg that's next to it. So if I'm looking at phi, which I circled here in red, you notice there's two sides here that are forming it, one of which we already identified as the hypotenuse. That's C. So the adjacent one has to be B, and it's going to be B over C. And you'll notice in part A, we also were over C because it was over hypotenuse. Sine was opposite over hypotenuse. This one is adjacent over hypotenuse. The other thing to notice is that we got the exact same answers here, even though one was sine and one was cosine. And the reason is we were looking at different angles. And so you can end up with the same ratio because we're dealing with different functions and different angles. All right, the last one we're going to look at is tangent. And so for the tangent, we are again dealing with tangent of theta. So part C, tangent of theta. And so I'm going to circle my theta so I can focus on that. And tangent, we want OA, which is opposite over adjacent. So the opposite one is the one that is across from it, and that would be B. And then we want it over adjacent. Again, if I look at this angle, there are two sides that are forming it, C and A, but C was already labeled as our hypotenuse. So I don't want that one. I want A, which is the other side right here, that is next to what we were dealing. So again, we end up with B over A. For whatever reason, that's not quite squeezing in. I'll rewrite it over here, B over A. Sorry for the technical difficulties here. So again, that's what our main goal was here, to be able to set up these trig ratios, and then moving forward, we'll actually do some algebra and use some technology to find these missing values. All right, until next time.